Hi, and welcome to the first of our Networking 101 videos. What we're going to do in this series of videos is just take you through basic network, how networks work, how different devices connect, and some of the underlying details about how computers communicate. So what we're going to be looking at in this first video is really the basis of what you need to understand. It's looking at, okay, two PCs connected together, but what happens, when they actually communicate? What is the process by which they are able to talk and send files to each other at the very, very most basic level? So we're going to be looking at obviously their IP addresses, which you may have heard of, MAC addresses, and maybe something you haven't heard of if you're new to networking, which is something called Arp. Okay, and how these work in order to establish this communication and be able to. And these, we're doing it with two computers, but it's really something that can happen. That's used even when a computer's talking to a switch or a router, or two routers are talking to each other on an Ethernet network and need to pass information. So once you understand this, then it carries forward and will build upon this video in future videos where we start to make things a little bit more complex and we start to introduce some more wide range components and networking devices into them. But for the moment we're just going to keep this one PC to PC to give the base understanding of what's going on there, and then we can apply that in future videos. So without further ado, let's dive in. So this is the lab we're going to be looking at today. As you see, we've got two PCs, PC1 and PC2, and we've got the PC2 will already have its IP address set up 192.168.7.2 with a 255.255.255.0 subnet mask or /24. Not going into too much detail on IP addresses, but what that means is the subnet mask tells us which part of the IP address refers to network portion and which part refers to the host portion. So in this case, with 255, that means that this is network. This first part, the 192.168.7 is network, and the .2 is host. PC1, we're going to set the IP address here. It's a Windows 11 Pro virtual machine. We're going to set the IP address here. And same IP address, same mask. Sorry, not same IP address, but same mask. 192.168.7 is the network portion. So because this is the same on both sides, we know that these two devices are on the same local network, but they've got different host addresses. PC1 has .1 host address and PC2 has .2 address. So what we're going to do as part of today's lab is we're going to carry out a ping between PC1 and PC2, a ping request. But in order for that ping request to work, PC1 needs to know how to find PC2. Because at the moment, it doesn't know. PC1 doesn't know about PC2 and PC2 doesn't know about PC1. Doesn't know what the address is, and they don't know, even though they're on the same connected cable, they don't know how to reach each other. So what will happen is when we send out a ping, PC1 will send out an ARP request. Address Resolution Protocol request to PC2. But it doesn't know how to reach PC2 because it doesn't know where it is. So what it will do, it will send out an ARP request using a broadcast MAC address, which is all Fs. So instead of being 50, it'll be FF, 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 FF. You get the idea. But what that means is that will send, when that's sent out on the local segment, and PC1 will send that out with its IP address and its MAC address. It will send it out to the destination MAC address of all Fs. And what that means that any PC connected to this local segment will look at it. It will see, it's a broadcast, and it will look at it and see if that broadcast relates to itself. So PC2 will pick up that ARP address, and it will look at it and say, yes, I am 192.168.7.2, who you're looking for. And what it will do, because that information has attached PC1's IP address and PC1's MAC address, it will put that into its Arp Cache. Arp Cache over here. And from there, what it will do then, it will send a reply back. So PC2 will receive that broadcast address, and what it will do an ARP reply back. But rather than send another broadcast, what it will do is it will send a unicast back to this MAC address because it has it in its Arp cache. So it will send back to this MAC address knowing that it relates to this IP address for PC1, and it will send an Arp reply back with, I am 192.168.7.2, here's my MAC address. Right, so we've reached a situation now where PC1 knows the MAC address and the IP address of PC2. It knows this IP and it knows this MAC because it's in its Arp cache. And also PC2 knows PC1's MAC address and its IP address because it's in its Arp cache over here. So now it has communication and both PCs know how to reach each other. So the ping can now take place across the network with PC1 pinging PC2. So let's now go and have a look at this actually in the lab situation. Okay, here we are on EVE-NG, and what you can see is what we've just discussed. We've got two PCs, Windows PC1 and PC2, connected directly together via the Ethernet 0 platform, the Ethernet 0 connection. Okay, we've already set the IP address 192.168.7.2 on PC2, and what we're going to do now is set the IP address on PC1. So these are Windows 11 Pro PCs. Okay, virtual PCs. This should be very similar. I'm just showing you one way of setting the IP address. So I'm going to go to Start, Settings, and looking for something like Network and Internet. There it is there. Now, here we go. We're looking on this side now for Ethernet. Don't worry about the fact it says no Internet access. We're not expecting any on these PCs. So we're looking for Ethernet. Now these particular ones have got two Ethernet connections, but we're not interested in Ethernet 2 in this case. So we're going on to what's showing here is the unidentified network, and you can see here we've got automatic DHCP, which is the standard and default you'd expect on a Windows PC. But we're going to set a static IP. So we're going to edit, and we're going to change this to a manual. And we were editing in this case IPv4. We're not doing IPv6 here. So we're just going to do 192.168.7.1, and the subnet mask, as we see over here, is 255.255.255.0. Okay, not setting a gateway, not setting a DNS. We don't need it for this particular lab. What we're just doing is connection PC to PC. So we're not working outside of, as we've discussed, our local network. These two PCs are on the same network. A gateway allows you a way out of your local network, so we don't need that here. So we could put something in, but we're not going to. So we'll just save that. You can see here it's set on here. Okay, so we'll close that for the moment, and what we're going to do now is open a command prompt. Okay, and we're going to just do ipconfig. And what we can see here with ipconfig is we can see here now nothing on Ethernet 2, but the Ethernet adapter that we're looking at, we've got our IP address set 192.168.7.1. Now what we can also do is check our MAC address here as well. So if you do an IP config /all, it shows you all of the details in the IP config. And if we look here, we can see the physical address here is 50.01.00.01.00.00 against this IP address that we've got set here. Okay, so that's exactly what we're looking for. That's exactly as we've got here on the sheet. PC2 is already configured. Something else we'll look at before we start is we're going to check the Arp cache on here. So we're going to do an Arp -A, which shows us the Arp cache. As you can see here, we've got no hardware address for 192.168.7.2. We're on PC1 here, and we'll go and look at PC2 in a minute and show that we can see the same thing there. So we've got no address here for PC2. We have got though the broadcast IP address here, 192.168.7.255. And you can see, as we've spoken about, the actual broadcast physical MAC address there as well against that. And what that's giving us is, if you don't know where the address is and you need to send out a broadcast, then send out a physical broadcast on this address, and that will be picked up by all other devices on your network in order to interrogate it. So it'll be sent out to every other device on the network. Now if we pull up PC2 and we do the same here, we open up a command prompt and do an what we'll do is we'll do an IP config/all, so we can check the IP address 192.168.7.2, and we can also check the MAC address, the physical address here, 50.01.00.02.00.00, exactly as we're showing on here. Okay, so everything matches up. And we'll also do an ARP -A. See the same thing on here. We have got no address for PC1. There's no registration in that table for PC1 at all. This currently PC2 does not know about PC1, doesn't know how to reach it on the network, and there's no reason to need to reach it at the moment. But again, has the broadcast address in here. Same broadcast address as PC1, 7.255, with the all F's MAC address for a broadcast on the local network segment. So we're going to go back to PC1 now. PC1. And before we do anything now, what we're going to do is we're going to do this ping across to PC2, which will get things all working, and we should get a reply from PC2. But before we do that, what we're going to do is we're going to set up a capture on PC1. EVE-NG allows you to set up a capture to capture the network traffic and display it to a program called Wireshark, which is a networking program that allows you to see exactly what's going on network segments. But we're just going to do it on PC1 in this case. Okay, so let's just grab on here, do a right click, and we're going to capture on our Ethernet 0 interface. Okay, which is what our connection is. Just give it a minute and it's going to start. Okay, it says, hey, what are you connecting on? And we're connecting on Ethernet, so we can just say okay. So now that's it. It's now, we'll just move it over slightly, and it's capturing. Nothing going on, as you can see at the moment, but what we're going to change that in just a moment. So what we're going to do now is we're going to do a ping to 192.168.7.2, and you can immediately see something's going on there in the background. We'll let it complete. Just give it a second, and we'll stop this capture. Okay, so we can have a look at it in more detail. Okay, so I've made it a little bit bigger. Now, what we can see when we started the ping here, so from I'll move it across a little bit so we can see our numbers here. So that at the top, we've got an ARP. So as we've spoken about, the first thing the PC does, because it doesn't know, PC1 doesn't know where PC2 is, doesn't know its physical address, it has to find out. So it sends from its source, from itself, there, using its MAC address, it sends out saying, well, I'm 192.168.7.1, who is 192.168.7.2. And if we click on that and open it in a little bit more detail, here we can see the ARP. So we can see the sender's MAC address, in which is PC1's MAC address, and we can see our IP address. And what this says is, well, actually, I don't know your target MAC address. So we'll see in a minute what it does. It sends it out as a broadcast. But I do know that I'm looking for 192.168.7.2. So if we just open up here, the Ethernet 2, we can see the destination broadcast, as we've spoken about, is all F's. Okay, and the source is our MAC address. Looking for PC2. PC2 will receive that because it's on the local network. And it says, ah, that's me. I'm the 192.168.7.2. And here's the reply. Okay, I'm 192.168.7.2. And this is my physical address that you can speak to me on here. So when we look at this now again, we can see it sends this back to PC1. But rather than using this time, sending it as a broadcast, it knows where it came from. PC2 knows where this request came from. So it sends it as a unicast message straight back. It doesn't broadcast it. It sends it as a unicast straight back to where to the source that it knows about. and it says, right, going to that destination from me. Okay, and here's the ARP detail. It says, okay, Ethernet, IPv4, sender's MAC address, which is PC2. This is my IP address, and I'm sending it via unicast directly to PC1 because I know about you. You told me when you did the broadcast. That information was in the broadcast that PC1 sent, along with the target MAC address. And it sends that back and says, and so then PC1 also has the information, and then it proceeds to do the ping. So from PC1 to PC2, an ICMP request, and you get the echo reply. Another request, reply, request, reply, request, reply. Get the idea, okay? Don't worry about the ARP piece at the end here. It just does another ARP at the end. But this is the important bit, okay? So it then, if we now go and look, so yeah, so this is the important bit, okay? This is what you need to understand, and this is really important for how every point-to-point communication works. Whether PC1 was a PC, or these were two routers, or two, whatever, two devices to a printer. In a way, it doesn't really matter. This is how a point-to-point communication works. And to understand how that works, that's repeated on Ethernet over and over and over again. For each hop, each connection you make, it's the next hop, the next connection, the next connection. And this similar, well, exactly the same sort of function takes place on a point-to-point link like this. In order for one device, this could be a switch or a router, to reach another device. More routers, we're talking layer 3 devices here. So it's how layer 3 devices communicate. Via a switch works slightly differently, as we'll see in the next video. But for a layer 3 device to connect to a layer 3 device, this type of ARP communication is set up. So now, if we go back to PC1, and now we do an ARP -A again, look, we can see that PC1 has PC2's address. It says, I know that 192.168.7.2 is at this physical address, and this is the address I can use to communicate with you. And you can see it set at dynamic, okay? And now if we look at PC2, there should be an exact corresponding back to PC1. And sure enough, there is. 192.168.7.1, I know how to get to you. You're via 50.101.00.01.00.00. So when I want to speak to you, this is the physical address I will use in order to connect to you. I know your IP address, and so at any time a layer 3 communication needs to go to 192.168.7.1, I know I can put my packet and encapsulate it with the physical IP address of this, and it will reach PC1. That will match PC1's physical address, and PC1 will be able to utilize the information that's sent and know that it's for PC1, and vice versa for PC2. So, in essence, that's it. That's what I wanted to cover for this particular video, just to understand what happens, because this is so important. If you understand this, then you understand how each jump of like this on a connection is made. Even when, as you see on the next video, we operate via a switch. It still works in the same way. There's some minor nuances which we will see that actually take place in the switch, but the connection between a PC and a PC connected via a switch still works in that same way. Still does the same thing. We just have an additional device that we have in the middle here that takes part in that communication, which we'll investigate in the next video. So hope you've enjoyed this. Hope you've got some understanding. Please, leave questions. If you're interested, please, it'd be great if you could, give us a like. Also, follow the channel. We'll be doing lots more videos covering all sorts of topics here. It's all very basic. This networking. It's not meant to be over complex. It's for you to understand if you really don't have a lot of networking experience. But please feel free to ask her any questions, and I'll be happy to, to answer as best I can. Hope you've enjoyed it, and I'll catch you in the next video.